Hey everyone, welcome back to the Internet of Things podcast. This is your host, Stacey Higginbotham, and your co-host,
Kevin Toffel.
And we have an awesome show for the 201st episode of the Internet of Things podcast. We're going to be talking about Bluetooth's new location services. We're going to be talking about a new smart lamp from a mattress company because everyone's got a smart lamp now. We've got new light switches, cameras in disguise, big companies getting into home electricity, a new way to harvest energy, and Japan is hacking people's devices for good. So we also have Ken Kolderup, who is the VP of Marketing at the Bluetooth SIG, who is going to be talking in detail about what we can expect from the new Bluetooth specifications, and he's going to explain what happened with beacons for us. And we're going to hear from this week's sponsor, Faircom. So all of this and more ready for you after a moment from another one of our sponsors. Guys, this week we're bringing in a new sponsor, Western Digital. Western Digital creates environments for data to thrive on your phone, in your car, throughout your home, and across cities. Everywhere data lives, Western Digital is there to drive the innovation necessary for the best results today and tomorrow. New devices, new systems, new solutions, and world-class data infrastructures, all optimized and tuned to create the right conditions for data to realize its full potential. Learn more at datamakespossible.com. That's datamakespossible.com. Okay, Kevin. We won't go too much into the Bluetooth news because we've got a deep dive from Ken Kolderup coming up, but we should tell people what's happening. So on Monday, the SIG said that they are announcing new location-based services for Bluetooth. Basically, this means that your Bluetooth low-energy radios, they will now be able to tell where they are within about a few centimeters, which is pretty cool.
It is, and I'm glad Ken is here because I wrote a post this week about what I think we could use this technology for. So I'm curious to hear what he has to say about the new feature in general. The feature is called direction finding. So with current Bluetooth solutions, like you may have like a Bluetooth tracking device, like a Tile or a tracker or whatever you might have, and you can use a mobile app and it will track the signal of that tracking device and kind of tell you how far away you are from it. As you get closer, you may find lost keys, for example. That's what I use a Bluetooth tracker for in my house. Direction finding feature takes it to a whole nother level and it's got a range of potential possibilities, such as indoor positioning, asset tracking, again, like you said, down to the centimeter level. My thought is, and maybe I'm thinking too hard on this could be huge for the smart home. And I don't think the smart home's going to see it right away. I think it's going to be more in like asset tracking, inventory type solutions at first. But if it comes to the smart home, think about this. You could have actual personalized presence detection with this to the centimeter level. Meaning, if I have a phone with this technology, or maybe a device like a clip-on to myself, or I put it in my pocket, for example, my smart home could actually tell where I am exactly in the house and who I am, because I would register that device to me. So now instead of like using a camera or a motion sensor that says there's somebody in that room, it could say, hey, Kevin is in his office in this spot. And when he's in this spot, he likes this music playing and this light on and this temperature and so on. This could bring a lot more context to the smart home. At least that's what I'm hoping.
You are right to hope for that. It will take a little while. Now, the way you've suggested it could work. So one of the challenges with this new feature is that handset makers are going to have to adapt their phones to put this in. So on the consumer side, you're not going to see it on handsets until people get new Bluetooth chips in there, which means new handsets. So that's a little ways out. On the industrial side, there are actually companies already using precursors to the standard. So that's happening already for asset tracking. With your idea, what you would have to do is basically buy a whole new cluster of goods. So you would have your dedicated thing, your clip-on belt loop, whatever thing, and then you would have to have some sort of beacon infrastructure that's new around your home with the appropriate antennas. But that could happen. And so we'll look for that. We'll see. And
that was supposed to happen, actually, with beacons.
Yes, it was. Well, again, you guys will enjoy the interview with Kit. So
Yes.
He goes fairly deep on all of this stuff and, explains what happens with beacons, which, hey, speaking of beacons, This is a weird use case, but I think it's weird because it doesn't feel like the most efficient. But Waze is using Bluetooth beacons in New York City's tunnels and bridges where you might lose your GPS signal. They're putting beacons every 40 meters roughly. So that's what, 42 meters per mile?
It's 42 beacons per mile, yes. And at a cost of $28 and change, it's about $8,000 a mile to implement this.
And the idea is you could be able to say, hey, when you're driving through, there's a beacon inside a car driven by someone, I'm not sure who, and that would actually tell you how long it takes to traverse that particular bridge or tunnel. I get it. I just don't think this is the best radio technology for that, but maybe it is.
Well, I mean, there are a few alternatives to good GPS signal. And when you think about the tunnels that they have in New York City, as well as the GWB, the George Washington Bridge, has 2 levels. So if you're on the underneath level, you might lose GPS because you've got, steel and stuff and cars on top of you on the top level. I'm not sure what the alternative is other than say, well, just no signal. I mean, you don't need it for directions, but companies probably want it for data, such as the traffic information. How long is it taking to get across the GWB today or through the Lincoln Tunnel?
That's true. And we don't have great vehicle-to-vehicle or vehicle-to-infrastructure communication. So
right.
That's
something else we've been talking about for a few years with Wi-Fi and other things. But don't worry, 5G will fix it all.
Oh, yeah, it's magic.
Oh, yeah.
Just layer some 5G on that. All right. That was sarcasm for everyone who was not aware. All right, let's talk about lighting, because there's 2 crazy lighting products out there. One is actually not crazy. One is a big surprise, I think. We'll go with the surprise first. Casper, the maker of beds.
Yeah, order online and get the mattress sent to your house in a box, and it expands, and that's that.
Yeah, I mean, I have a Lisa mattress in our house, so it's not a Casper, but same idea. Casper pioneered this. It was lovely. They're getting into the smart home space with a lamp. It is called the Casper Glow, and this is actually a pretty cool device. You know how I always tell people I need things to be smart? This is actually pretty smart. It is designed to dim and brighten based on your circadian rhythms. So different type of light in the morning versus at night. It is designed to gradually dim at bedtime. I've actually had Hue lights that have been designed to do this. So this is not totally new, but it is kind of a pretty and a neat form factor, and it does not require a hub. So it also has this ambient light sensor, which apparently modifies the light for the environment you're in, which is kind of nice. I'm like,
yeah, it kind of gets rid of the blue light. It emits a warm hue based on the ambient light. So that way it's not messing with your sleep patterns.
And the cool thing is you turn it off by flipping it over, which
I thought that's a clever implementation because both ends of it have like power or charging. So yeah, you just flip it over and it still stays on or goes off and it's not losing power that way.
Yeah. And then there's a bunch of other stuff. Now, the other cool thing is it's portable, so you can bring it places. Obviously, you have to charge it for normal use most of the time, but you can bring the glow with you. So they talk about, going to the bathroom in the middle of the night or getting a drink of water. You can bring the lamp and it will glow softly for you. Mm-hmm. That feels like something I would need to see to believe, but
I have solar-powered LED lamps in my house for the zombie apocalypse, so I keep one by the bed in case we ever need to stumble around the house. I can literally just lift it up from the base and it lights up. So it's not smart, but it works. I doubt it lasts as long as the glow because you can have this be on continuously for up to 7 hours on battery.
These glows will not come cheaply. The single glow will cost $89, and a 2-pack that syncs together will cost $169. So, Kevin, are you in?
I think not. I can only sleep for 4 or 5 hours at a time anyway, so I'll just stick with my connected bulbs in my bedroom.
Okay, so sticking with lights and circadian rhythms, a new startup has come out called Oro. And Oro is a connected light switch that, I know, there are so many, you guys, but this one is a little bit unique. It actually reminds me of the Stack lighting, but those were bulbs a few years ago that kind of had both AI, motion sensors, presence detection in the light bulbs, and they would learn based on your habits, and the bulbs would dim and figure things out, and it was magic. I tried them out. They were pretty good. They weren't as magic as I thought they'd be, but they did get better over time. The Oro does all of this in a light switch. So the switch, you replace it. It requires a neutral wire. It sits on your wall. It can detect when someone's in the room. It learns your habits over time. And it basically tunes the lighting to, again, your circadian rhythm. So cooler light in the morning, while doing stuff, and then dimming and turning orangier at night.
Yeah, what I like about this is the number of sensors in here, because there are light switches with just motion detection. They're not what I would call smart. They just replace one type of switch with another. They detect motion, the switch goes on. These have, I think, 4 sensors in them. So it detects motion, but also sound, proximity, and the ambient light to understand when somebody's in the room. So aside from the smart learning aspect of it, I think these would be better or more effective than just a traditional motion sensor switch.
Agreed. Now, these are
all those
pricey.
I was going to say, all those sensors and those smarts come at a price.
They're $199 per switch, and that is a single gang switch.
Ouch.
Yes.
Ouch.
It's expensive. So this is probably, actually, it's not that much more expensive than outfitting your house with something like the Noon switches. And those, if you guys recall, are switches that have pre-programmed lighting recipes already in them. And they basically figure out what lights you have in your house and then create the recipes based on that automatically. So again, what we're seeing is more automation, more AI coming into this. What I'm curious about is when you live with these, how the AI meets up with your real life, because that's always the question when we start automating this type of stuff.
Right. It's one thing to say it can learn, but how well does it learn?
And how much patience do you have? Because remember when everyone, remember when Nest came out and everyone was like, I hate teaching my Nest.
Yep.
And people still have issues. I mean, mine have mostly subsided, but part of that was just a learning curve. And, we'll see how that works with something as integral as lighting. That's something you notice right away when it's not right.
Yep.
Okay, in the creepy factor for the week, we have Panasonic launching a home security camera that's part of a floor lamp. It's the HomeHawk floor lamp. This is on Kickstarter, so this is, maybe no one will fund it. But basically, this is it's a lamp with a hidden high-definition security camera built in. And I don't love cameras in the home. You guys already know this, but I think The Verge put a story out about this and was like, God, this is an Airbnb nightmare. As someone who's stayed in Airbnbs and found cameras, I'm like, yeah, now I'm going to have like CIA level bug detection happening when I go and stay in an Airbnb. Ew.
Yeah, well, I mean, it is integrated. The camera is integrated into the lamp. It's not truly camouflage, though. If you take a look at it, you can see the camera sensor and so on. So, I mean, if you're looking for it, you'll see it. If you're not paying attention, maybe somebody has it in their house and you're in their house, you might not notice it. I mean, I wouldn't walk around and check everybody's lamps before I, decided to stay in that house, but it's not like totally hidden. So it's not, but it's not for me. That's for sure either. So.
And I should clarify, it is on Indiegogo. It is not on Kickstarter. My bad, you guys. So I don't like this. I don't like,
Yeah.
Sorry.
The one nice thing I will say, it plugs into a wall like any traditional lamp, and you don't need a smart bulb in there or anything like that. But if the power goes out, this can all run on for up to 90 minutes on 8 AA batteries. So you have a backup power source for your camouflage camera.
Yeah. You're never going to make me like this. Okay.
It's got a mic and a speaker. You can talk to somebody from far away right from the lamp.
Stop letting you get your feet off my couch. I mean, I could see why homeowners want to do this, but I'm also kind of like, if the trade-off for the sharing economy is surveillance constantly, that's not what we're signed up for,
No. There are other countries to move to if you want that.
Anyway, all right. So let's talk about Google and Amazon getting into electricity. For Google, this will actually be the second time around. They actually had a smart energy program. So did Microsoft way back in 2011 and 2012. But this is a story from the Wall Street Journal talking about how the big players are looking at home automation and all the data that's being produced and realizing, hey, we could be better energy stewards, better utilities.
It's smart. I mean, we always wonder what our company's doing with all of this smart home data. Some of it's probably not good, but some of it is good. I think this is. And a perfect example from the Wall Street Journal story is that during a solar eclipse in 2017, obviously everybody who had solar panel wasn't generating any electricity, which could affect the grid as well, because a lot of solar panels are still grid tied. So they feed energy in when they have an overabundance of it. And Google apparently encouraged Nest owners to opt in to a program that cooled off devices. I guess this was in the summertime during the eclipse, cooled off their homes rather before the power supply fell because of the eclipse. And then during the eclipse, the thermostats turned the temp up by a few degrees so that air conditioning was not running. And apparently they had 750,000 customers participating, and they reduced the energy consumption by 700 megawatts, which is no small bit of power.
Oh, yeah. And this makes sense. Demand response has been around for a while. Utilities have participated in basically controlling you sign up, you control someone's thermostat, and you can say, oh, we've got a lot of demand right now. Let's turn everybody's thermostats up by a little bit. People can opt out of these programs. But when you start having more connected devices, you can actually start making an impact across a wider swath. And they're still the biggest energy consumption devices in the home are HVAC, so HVAC, air conditioning and such, and water heaters. And there are already utilities that are looking at connected water heater companies and saying, hey, maybe we could control that. After that, we get into washers and dryers are big consumers, ovens. Whirlpool, I know, has talked to utilities about this, but it would be much easier for one monolithic company who has access to this data to do these types of things, as opposed to like a Whirlpool making deals with, I don't know how many utility providers there are across the US, but there's more than just two. So,
right. And there's a consumer benefit too. This is one of those times where giving up data gives you something back in return. A lot of regions have variable energy rates. And if there's, a very high demand, rates can skyrocket. So if you've pre-cooled your home, for example, you might be able to do so at the lower rate and just kind of weather the storm where demand is high and therefore prices are high. So you may actually pay less and still feel relatively the same comfort level.
Right. That is the goal here.
Yeah.
It doesn't always happen as someone who's dealt with demand response, but that is the goal. Okay. Speaking of energy use on a smaller scale, a team of researchers out of MIT has developed a material that could lead to a breakthrough in energy harvesting, and that is grabbing small bits of energy to power sensors or tiny battery-powered devices today. This is really important, you guys. The Internet of Things, we cannot be changing batteries if we're going to have 50 billion connected devices. We have to have things that have energy harvesting capabilities. So, this particular research has basically created a two-dimensional material that is 3 atoms thick that can convert radio signals from any sort of radio, so Wi-Fi, cell phone, or whatever, into power. This is pretty cool, Kevin.
Yeah, it's really cool. I mean, they call it a two-dimensional material because it's so small, 3 atoms thick. It's a film made of molybdenum disulfide, and I probably pronounced that wrong, but yeah, it can act as an antenna, but additionally, it can harvest energy from the radio waves that antenna is gathering as well. So you're not going to generate tons of electricity this way, but for small devices, small low-powered devices, maybe a wearable, that's probably pushing it, but maybe you could essentially maybe have no battery in it, perhaps.
And these are the effort to get power out of RF signals is not new. This is actually something that's been happening for a long time. You could actually even think of things like, hey, wireless power is basically that. These sorts of things are being researched in lots of different places. Right now, what's interesting is today we only have a couple energy harvesting technologies. They are Piezo, so movement-based, so clicking, changing things, anything kinetic. Temperature differences can also generate power. And then solar, so light. Those are all probably more efficient at this moment, and they're not very efficient, especially at small ranges. I mean, solar's pretty efficient, but if you've got a small device, you have a small solar panel on top of it, it won't generate as much. But, we've got to get better. We've got to do more. So it's really important to have this type of research out there.
Right. And as you said, this has been around for a while in practice because anybody who's used an RFID card, say to enter a building, for example, that has an antenna in it and it has no power. There's no battery. But when it receives a signal, it can get a little bit of juice, just enough to basically say, hey, send a signal back or read the signal in and therefore unlock a door, for example. So we have this technology, but we're not using it in ways that we need to for IoT.
Right. So let's go from cool energy harvesting. Let's keep that up, y'all, all the way to Japan. Kevin, what are the Japanese doing?
Well, the Japanese government is going to hack into millions of Japanese citizens' connected devices. But it's not a bad thing. It's actually being done to improve cybersecurity. So what they're doing, and by they I mean Japan's National Institute of Information and Communications Technology Group, is going to basically use default passwords and password dictionaries of basic passwords. And they're going to try and break into about 200 million devices. They're going to start with webcams and routers. So I don't know if they'll actually move beyond that into phones and other things. But regardless, when they do that, if they are successfully gaining access to a device, they're going to contact the owner of that device to advise them, hey, you might want to change your password. I'm not exactly sure how they're finding out who owns what device out of 200 million devices, but that's on them. But I think this is a great program because too many people, the weak link is that password, or maybe it's the router in the home and so on. So this is a thing for good, not for evil. So this is one hack that I like.
Yes. Okay. And finally, let's talk about Amazon making it easier to build skills for Madame A.
Yeah, if you're a developer and you're making Amazon Echo skills, you may be doing two things. One, building the skill, but two, worrying about all the back-end stuff on the server to host it and do processing and so on and so forth. And Amazon actually has a beta program called Madame A Hosted Skills. And that is now available to all developers. It was very limited in a private preview, but it's open to everybody now. And what this does is, instead of worrying about the hosting for your AWS Lambda bits and all, Amazon will actually just host it for you. And they have a free tier with access to AWS Lambda, 5 gig of storage, and 15 gig of monthly data transfer. So you don't have to worry about setting up a server or setting up some instance somewhere else on the cloud that's not Amazon. It basically takes all that away. And that way you can just focus on skill development.
Yes. And I have an update from last week. So last week we talked about smart apartments. I assume you guys, we talked about a particular woman who was on Twitter talking about how she, as a security researcher, was not comfortable with her apartment going with automated door locks mostly, but just an overall automated system. We talked about why we thought, hey, this may not be the best implementation of this because she wasn't given any choice. Well, Leslie Carhart, who is the white hat hacker who did this, she actually wrote a blog post about it, talking about security things to consider when your apartment goes smart. And she talks a bit about the situation, but she also brings up some really good points that I think are worth sharing with everybody. So she talks about, when assessing this sort of thing, what is your threat model? And for her, it's pretty high because she is a professional hacker of nation states and other people. And, those kind of people, they might often become targets. So that, for her, it's a big deal. For maybe Kevin or I, it might not be a big deal, especially because we live in a single family home. If someone were going to go through the trouble to want to break into our house via our door locks, they'd probably be better off just using a screwdriver or a crowbar, right?
Right. Yep.
Now, in an apartment building, because there's the potential for someone to be able to open a bunch of doors at once, that does change the threat model there, even if you're a nobody. So that was one point that I thought was interesting. And then she also did a really deep dive, and we'll link to this, into how you define a smart lock and how basically keyed locks are taken care of, how revolving PIN codes work, etc. And it's actually a really good look at both how the locks work and different exploitation methods that have been used to break them in the past. So,
did she say she's moving?
She did not say that she is moving.
Okay.
And then she went into the issues associated with the hub. We've talked actually about a lot of these things. And to her credit, she actually talks about why a landlord might want some of this stuff. And I do think that there are benefits to a landlord. And if done correctly, everybody wins.
That's the thing. I don't think any of us, either you, me, or her, have an issue with smartifying an apartment. It's the implementation that's being done in this particular case.
Yes. So I love this story. I love the depth in which she goes. You should probably check it out and maybe assess how you feel about your own smart home and security in the wake of this. So, all right, now, I know that's an odd note for someone like me who's like, I put all kinds of craziness in my house. But I actually do consider every device I bring in, and I talk to people about the security of every device that I bring in. So it's not this crazy pell-mell adoption of technology that it might sound like it is from the show. So, okay. Now it is time for our IoT podcast hotline voicemail. So this week we have a new sponsor for the hotline, except it's an existing sponsor that you guys are probably really familiar with. Affero has taken over this month's sponsorship of the IoT podcast hotline. Affero makes a platform that helps companies get their devices on the Internet of Things. Kenmore and D-Link have both used Affero, and as part of that, they have experienced as much as an 80% reduction in time to market, 99% fewer support calls, and 10x higher activation rates. So, if you were in the market for an IoT platform provider or someone to help you build your connected products, go visit affero.io to learn more. That's AFERO.io. Okay, and this week's caller is Monty, who wants to find an appropriate Z-Wave hub. Let's hear from him.
Hi, Stacy and Kevin and Norm, if you're listening. This is Monty from Salt Lake. I'm just starting to do some smart things in my home, and I'm trying to find a best hub for Z-Wave stuff. What's a good hub that I would use? Thank you.
Okay, Monty. I'm actually going to steer you away from a hub. If you are just beginning, I don't know if I would recommend bringing Z-Wave into your house. And I think there are plenty of other options, even in the sensor department, that you could get away with just using Bluetooth and Wi-Fi, and probably something like a Google Home or a Madam A. If you hate that idea, though, Kevin has some excellent Z-Wave recommendations for you.
Yeah, since Monty says he's kind of just getting started out, I would say let's keep it simple and go with either a Samsung SmartThings hub or a Wink hub, because both of those would have Bluetooth, Wi-Fi, and Z-Wave. They're not too expensive. They're relatively easy to set up. If you want to get into a little more technical solution, Hubitat would work for you. But again, it's not for somebody who's just starting out. I'm actually in the process of finishing up my review of the Hubitat. And even as somebody who's been playing with these things for the better part of 8 years, it's a bit of a learning curve on setting up and automating things. I actually did come up with 2 other options for Monty. If you're looking for a Z-Wave hub and you're also in the market to add some smarts to a television set, you might want to think about the NVIDIA Shield TV box, which is an Android TV box, so you can stream all kinds of online things, services, pretty much anything and everything other than iTunes right now. And what you can do is they sell a SmartThings USB dongle, which turns it into a SmartThings hub as well. So it's 2 for 1. You're going to pay more, obviously. You're looking at probably about $170 for the NVIDIA Shield TV and then another $30 to $40 for the dongle. But I just wanted to put that out there. So lastly, if all you want is a Z-Wave hub, and I don't think that's what you want, but just in case, Fabaro actually, they make the home center too. It doesn't have Wi-Fi, it doesn't have Bluetooth, but it does have Z-Wave. So it's a niche use case. It doesn't give you probably what you want in the future, but it's something to consider as well. Ideally, though, I would go with Wink. That's just me. It's relatively the easiest one to use, and it's been rock solid for me.
I will endorse Wink and SmartThings as a distant second if you are willing to get into some kind of if you're really into DIY, SmartThings is the way to go.
Yes.
Again, I would encourage you to look for Bluetooth and Wi-Fi solutions. You actually don't have to go Z-Wave anymore. There are even Bluetooth and Wi-Fi locks out there. There are plenty of light switches. Yeah,
it depends, Monty, on what you're trying to make smart. I would take a look and see what options that device or devices have. If they're just Z-Wave, okay, you need your Z-Wave hub. But if there are options for Bluetooth or Wi-Fi for the same products, I'd consider those. We've talked about this quite a bit in the last few months. It seems like the industry is just simplifying and going with a consolidated Wi-Fi and Bluetooth solution in the smart home these days.
Yeah. And if you decide that, I don't need Z-Wave, but I really want Zigbee, you could get the Amazon Echo Plus, which is a slightly easier user experience, but that won't work with every single Zigbee device out there. So just bear all that in mind. When you add the Z's, you're adding complexity. All right. If you guys have a question that you would like us to answer, please give us a call on the IoT Podcast hotline at 512-623-7424. Next week, we will announce our January winners of this is a Google Home device. It was a used Google Home device as part of my spring cleaning / oh my God, I'm moving. I will be giving the winner of our February contest a Wemo Switch. So it is used, but it is in lovely condition and even will have the box. So if you want, call us at 512-623-7424 and you will be entered to win. If you call before January 31st, you will be entered to win a Google Home. If you call after that, you will be entered to win a Wemo Switch. This is a Wi-Fi dimmer switch. It's lovely. All right. That's it for the news portion of the show. Now, Stay tuned for our guest, Ken Kolderup, who is VP of Marketing at the Bluetooth SIG. He'll be talking about Bluetooth's new location services, what happened to beacons, and more. Hey everyone, we are taking a quick break from the Internet of Things podcast for a message from our sponsor. This week's sponsor is database provider Faircom, and we have Evaldo Oliveira, who is here to talk to us about Faircom's new C-Tree Edge database. Evaldo, Faircom has developed this database for the edge, but what about the cloud? What role does it have for edge computing, and how can a database help?
The cloud is absolutely critical for IoT, including for edge computing applications. There's no question about it, especially because of the incredible amount of processing capacity and elasticity that the cloud brings to the table. However, some of the limitations that the cloud has, they might be a problem for edge computing. For example, latency. Typical cloud latencies like hundreds of milliseconds are way too high if you're trying to control some heavy industrial multi-million-dollar equipment. Imagine that some critical sensors has been triggered and indicating an obstruction that may damage your machine, that you have about 10 to 20 milliseconds to stop the machine. This cannot be done with the cloud as part of the critical path. In such cases, a much better alternative is to make sure you have all this data readily available on the edge, right beside the machines you're trying to control. So that's where our database really makes the difference.
And how does that help an edge application developer?
Well, your edge application needs to be able to read this data as fast as possible with minimum layers in between the application and the data itself. Making sure you guarantee that this data is also properly persisted is critical for later audits, for example, if you need to investigate root causes of what created a problem. And last but not least, keeping the sequence of the events like any typical transactional system will help you to understand the events that trigger the situation. These are all features of what we believe an IoT database needs to provide, and they're all covered by C-Tree Edge.
Excellent. So can you explain how C-Tree Edge helps customers to address all of these concerns?
Sure. C-Tree Edge was really designed with these requirements in mind. Let's talk about throughput, for example. C-Tree Edge provides an ultra-fast key-value store interface for applications to query the data directly, without typical extra layers that a SQL database usually introduces. Complex SQL relational queries are completely unnecessary for IoT sensor data processing. It's the perfect example of using all the power of a key-value store engine to support real-time processing. Another good point is the guarantee of persistence and transactions. C-Tree Edge's core engine is a fully transactional database, guaranteeing ACID compliance, relieving the application from concerns like making sure the data is properly written to the disk or the solid-state drive. Auditors can rely on the database to know for sure that the historical data of any past event is safely stored. Transactions also guarantee the ability to replicate this data automatically to a remote location like the cloud. This is an important feature that C-Tree Edge can provide and do it for you without the need to develop an application that does that. And as we talked about last week, C-Tree Edge is highly secured with 256 AES encryption. And finally, C-Tree Edge also provides what we call an IoT microservice layer that makes the integration with your Edge application much easier, like providing an embedded MQTT broker as part of the solution.
So where can our listeners find out more information about Faircom's C-Tree Edge database?
Well, we just published a great video showing a live demonstration of how to use C-Tree Edge. It's an example running on a Raspberry Pi that collects data from sensors in real time and persists the data. You can check it out on our website. It's available at faircom.com/IoT.
Hey everyone, welcome back to the Internet of Things podcast. This is your host, Stacey Higginbotham, and today's guest is Ken Kolderup, who is VP of Marketing at the Bluetooth SIG. Hi Ken, how are you doing?
I am doing very well. Thank you for having me on the show today.
Excellent. We are glad to have you because Bluetooth is, I'm going to go with, pretty important for the Internet of Things. And there's a lot going on with Bluetooth. About a year and a half ago, you launched Bluetooth Mesh, which we'll cover, I'm sure. But this week, you actually just launched a new capability, which is better location finding services. Can you tell us a little bit about that?
Yeah, over the last couple of years, as you mentioned, we've been introducing, and the community really is the one who does all the work here, adding a number of new capabilities to Bluetooth to help out in either opening up new market opportunities or trying to do a better job in some of the areas that Bluetooth already plays. You mentioned Mesh, some things we did with Bluetooth 5, longer range connections, faster speed connections. And so now the community actually just this next week is going to be adding a new capability called direction finding. What's direction finding? At a very high level, this is a new feature that will enable one Bluetooth device to determine the direction of another Bluetooth device. Or on a slightly more technical note, it'll enable a Bluetooth receiver to be able to determine the direction of a signal that's coming from a Bluetooth transmitter. So very simple concept. One Bluetooth device can now understand the direction of another Bluetooth device. The reason this is so important and kind of the implications of this is the members really added this capability to help out in this whole location services area where Bluetooth has been seeing a lot of growth over the last 3-4 years. And what's going on here is that today, if you're familiar with Bluetooth location services, everything from these kind of consumer level item finding products like those tiles and trackers, those little, personal asset tags you can put on your keys, your wallet, or things like that. So either those kind of more simple consumer level solutions all the way up to very sophisticated, enterprise level real-time locating systems that are used to track assets and people in kind of locations like hospitals and factory floors. All of them, they use the same basic simple building block with Bluetooth. And that's the ability for two Bluetooth devices to really understand when they're in range of each other and then to use signal strength measurements to kind of estimate the distance between them. So that little basic capability is what's been powering this whole location services market, which is expected to go to almost like 400 million units here in the next couple of years.
So basically, this is the equivalent of standing in a crowded room and shouting, here I am, and someone else gauging how far you are from basically, oh, sounds like she's about 20 feet away.
That's right. So we use, and Bluetooth uses signal strength, how loud do I hear you, to then estimate how far away you are. And these solutions work really well. But now imagine if my smartphone can not only use signal strength to determine the distance to another device, but it could also understand signal direction. So now that app on my smartphone could now not only tell me how far away it is, but it can actually point me in the right direction, which would make finding my keys a whole lot easier.
Agreed. So when we're talking about direction, this means like I'm going north or south or right or left, or how does that work?
No, this is actually just the direction. So go back to that analogy of you yelling and me trying to hear you. Not only can I kind of guess by how loud I hear you, I can guesstimate how far away. Now I can actually determine which direction you are in. So I know, oh, she's over that way, right? It's not north, south, east kind of direction or coordinates. It can just understand where that signal is coming from. So the voice out of your mouth, I can kind of understand where it is. In this case, Bluetooth, a Bluetooth receiver can understand in which direction a Bluetooth transmitter happens to be. 360 degrees around you, wherever it might happen to be, it can now say, oh, it's that way.
Okay. And so if I'm a developer and I'm building an application that wants to take advantage of this, how would I implement that for the end consumer? What does that mean for, developers building and then people who they're building for? There's another use case I want to talk about, which is probably where we're going to see things happen sooner. But in this one, this more consumery one, this one requires the handset guys to add this capability. And that's some things some pretty sophisticated things they need to do, including the addition of an antenna array inside the device itself. So that may take some time, but once that's done, I would presume that the handset vendor, in coordination with their other suppliers, would then surface some APIs to the developer community that would be able to then get the information from the Bluetooth radio in order to determine signal direction. And then that could be built into various applications like this item finding one we talked about. So this is the application you expect to develop first, or is this the other more consumer-friendly one and there's a different one that will develop first? Yeah, anytime we introduce a new capability and it's necessary for the handset vendors to include it, that takes time. There's handset cycles that are involved in that and so forth. There is another key area of location services where I think we might start seeing direction finding included sooner, and that's in those more sophisticated solutions I mentioned earlier, those kind of enterprise level real-time locating systems like asset tracking and things like that. So if you look at those, they use that same basic building block we talked about earlier with two devices understanding range and signal strength measurements to estimate distance between them. But in this case, there are a number of Bluetooth locator devices that are deployed in fixed locations throughout the building. And those locators are constantly listening for Bluetooth tags that are attached to various mobile assets or people within that. And that system is tracking the locations of them. And the way that works is each of those locators is also reporting back to a central server all the tags that it can currently hear, as well as the signal strength from each. In other words, it's distance from the locator to each of the tags that it can see. And using that data from all the locators, the server can then kind of calculate exactly the physical location of any tags, as long as
3 or more locators can see it. And today, using that kind of technique, which we just talked about, these systems are able to determine the location of something with so-called meter level accuracy. They can figure it out. It's right here within kind of 1 to 10 meters, depending on a lot of deployment considerations. But now a signal direction, now these locators can not only report back to the server the signal strength coming from the tags, but also the direction. So not only do I hear it at a certain signal level, I also know it's that way. And by reporting back all that additional information, the server can now dramatically improve its accuracy of determining where something is, going from kind of meter level of accuracy down to true centimeter level, if that's what's required for the deployment. So these systems, where the handset's not necessarily involved, it's just locators and asset tags and things like that. That's where I think you'll start to see this direction finding feature brought first. And there's actually commercial Bluetooth-based systems today that are doing it. They're just doing it with a pre-standard implementation of this direction finding capability. And so that's why I think they'll be coming to market sooner. Is I think some of those folks may be, upgrading their kind of existing systems to now the true standard implementation of it.
Got it. So you said within centimeter accuracy, which is pretty impressive. And then also, does this have a sense of up and down? So if I'm in a multi-story building, can I find things that way?
Right now, if it's required, and there are vendors out there that are doing the pre-standard implementations where they're able to track the position of something in real time within 10 to 20 centimeters. So really, really precise accuracy. And I think one of the vendors is actually using it in kind of hockey applications where they're tracking players and the puck as it moves around an ice rink. And yeah, the nice thing about this is when you have this angle determination, if you have multiple locators all getting a angle determination or a direction of that signal, now you know elevation as well.
Okay, so when should we start seeing, you say soon, now that the standard's out there, when will we start seeing this in enterprise applications? And then when will we see it maybe in consumer? And yes, the handset cycles will matter.
That's right. So I think in these enterprise applications, certainly this year, I think we'd expect to see some of those potentially existing systems upgraded to the true standard and potentially some others that are in the space adding this capability. There's more consumer level applications that require some work on a handset. Yeah, it's always hard for us to give guidance there. That really is up to a few players out there. And we certainly hope that they take a look at this and add these capabilities. And maybe this time next year, we're seeing some stuff come to market.
Okay, and let's talk about some of the news you guys discussed at CES, which was profiles. And, if I can take folks back down memory lane for a while, Bluetooth has been around for a long time, but historically I say historically because I'm old. I'm like, historically, it was focused on audio and being able to transmit, audio to your speaker, to a Bluetooth speaker, audio to your headphones. And now we're really taking something that had a pretty narrow focus and turning it into something that is really applicable for everything from, sensor readings all the way up to location and even things like, light bulbs. So talk to me about kind of the journey that Bluetooth has made and the concessions the SIG is trying to make as it tries to build out these use cases that are hugely varied.
That's right. I think, and I mentioned a little earlier, that's one thing that's always impressed me about the Bluetooth community. It doesn't stand still. The community is continually adding new capabilities to address new markets. And that's at multiple levels. I mean, if you go back far enough, some may recall there's the Bluetooth classic radio, the BR EDR radio, and then the community added a whole new radio, the Bluetooth low energy radio back in 2010. And that opened up a whole lot of opportunities in and of itself. But not only at the radio layer, but even now that you look at more the ways that Bluetooth enables devices to connect. So initially, as you mentioned, it was all about audio and kind of simple point-to-point connections of streaming audio between my handset and a speaker or something like that. But it also expanded to broadcast communications. So allowing one device to communicate to many around it. And that's what's powered the whole Bluetooth beacon revolution, as we like to talk about, and many, many use cases for using Bluetooth broadcast topology, if you will. And then, as we talked about earlier, about 18 months ago, the community added yet another way with mesh networking. So allowing tens, hundreds, or thousands of devices to all be able to communicate to each other in a many-to-many kind of topology. So they could all securely, reliably, and with high performance be able to exchange messages with each other. And that was brought to market to really be a catalyst or an enabler for a lot of these emerging markets like smart home and smart building, where you have that need for many, many devices to be able to securely and reliably able to communicate with one another. One of the markets that this mesh networking technology was targeted at is the smart home market. And, there's been a lot of progress there. That market has evolved a lot over the last couple of years. In fact, if I take a little bit step back, Bluetooth, we look at the smart home in two different ways. One is as the kind of connected home and then kind of true home automation. Connected home is where Bluetooth is being used to just connect lots of things in the home. It's kind of the stuff you alluded to earlier. TVs are connected to sound bars, game boxes to controllers. My smartphone is connected to tools, toys, toothbrushes, lots of things in the home. And there's probably 500 million products shipped just this last year alone in that market. And then there's the kind of full home automation area where, involves more sophisticated solutions being deployed for control and automation of the infrastructure in the home, lighting, heating, cooling, security, and things like that. And that's the one it's a much more nascent market, although we are shipping almost 100 million units this last year in that area. But it's one that I'm excited to see a lot of progress being made. And in the last couple of years, we've seen, for me, it's been good to see the big tech players, stepping in here and providing kind of this next order to some of the chaos that's been in this market for a while. So, Google and Amazon domestically, Alibaba and Xiaomi, for instance, in China. And these companies are really coming in and they have the wherewithal to really pull things together to create large enough ecosystems to attract the developer community and to deliver truly kind of compelling experiences and things like that. And we've been excited about that happening because I think that's going to represent the next growth. And we've had several of these big ecosystems now make the kind of strategic decision to select Bluetooth and specifically Bluetooth Mesh as a key protocol for their overall smart home strategy. And we've seen lots of growth. So even since the last 18 months, the number of products that are Bluetooth Mesh qualified have been really doubling almost every 6 months. So after the 6 months since we launched the spec, there were already 30 qualified products. After 12 months, it was up to 60. After 18 months, which was just about a month ago, there were over 120. So it's been growing really rapidly on this kind of doubling after every 6 months. And based on everything I'm seeing, I think we should expect that to continue for a while here.
All right, let's talk about the enterprise and industrial uses. I know that there are a variety of hub makers and companies from Cassia to Rigado who are trying to help bring and make Bluetooth a little bit more accessible for enterprises. How is that going? And what are kind of the things that those use cases need that we should be considering?
Yeah, I think as we talked about, there's a couple of emerging markets for Bluetooth which represent really big growth opportunities. And the enterprise, or we just generally refer to it as the smart building market, is absolutely one of those. Right now we're seeing really strong growth on a couple of fronts. First, it actually relates to the one we were talking about earlier, is in this whole area of location services, which has been building very well for a couple of years now. And also Bluetooth, indoor positioning systems for things like wayfinding. So large facilities and enterprises, things like shopping malls, deploying those systems to facilitate visitors' navigation throughout it, airports doing the same so visitors can find their way to gates and amenities throughout it. So that whole location services area has been growing really, really well in the enterprise market. The other newer area in smart building has really started with this whole launch of mesh networking about 18 months ago. And the big bright spot there, no pun intended, is actually lighting control. And what we've been seeing is that many commercial buildings of all types are kind of making this rapid shift from compact fluorescent lighting to LED lighting. And at the same time they're doing that, they're looking to move to wireless lighting controls. It provides lower cost, greater flexibility, a next level of sophistication to meet new regulatory requirements, things like that. And that momentum has been building, very well. So we've been seeing a lot of lighting vendors, both on a commercial and residential, but really on a commercial front, especially over this last 18 months. So that whole shift to kind of smart connected lighting seems to be a really, really good growth area for us right now. And I think Bluetooth with mesh is very well positioned there.
And as Bluetooth evolves, I'd love to talk to you about beacons because they felt so promising and then they ended up being so not promising. And yet a lot of the technologies we're talking about in this conversation are things that we thought we'd do with beacons. And now we're basically going to do it with gateways and other devices. So can you kind of talk to me about, I guess, what happened with beacons and then how that concept has adapted to maybe what we hope we need?
Yeah, sure. I think if you take it back far enough, this goes back to what happens with many technologies, I guess. And by the way, I think it's actually going quite well with beacons. But back when the community added Bluetooth Low Energy, one of the things that got introduced with that was the ability to do broadcasting, right? We talked about a Bluetooth device can now just broadcast out messages, and any device around it can hear those. And the community's been very creative with ways to use that, and that's what led. If you remember a little bit of the progression, Apple's the one that introduced the iBeacon protocol as a means to kind of figure out how to use that capability to support point of interest information beacons or using the broadcast topology to serve a variety of different opportunities. Now, I think there's a lot of interesting ways to use Bluetooth broadcast. One is to support these point of interest information beacons. So we still are seeing a lot of museums putting these beacons on exhibits to allow visitors to get more information about it. Retail environments are deploying beacons on various products and end aisle displays and so forth to facilitate a shopping experience. So Bluetooth broadcast capability servicing these beacons is still a very growing market. But that broadcast capability of Bluetooth is being leveraged for many, many different things. So it's actually the fundamental technology behind Bluetooth Mesh. So all the devices in a mesh network are actually using broadcast communications as a way for them to communicate to each other. By the way, is this answering your question?
Yes, it is. And this is partly, this is, as you point out, this is technology adapting. This is basically like, we're going to put a capability out there and see how people react to it and what they do with it. So this makes sense.
Okay, here's another thing I'll add on to that. In another area, so for instance, and there still are many, many sensor solutions that use Bluetooth. They can choose any different way to communicate using Bluetooth. They can use Bluetooth point-to-point connection back to a gateway. They can use a broadcast communication, this kind of beacon communication to communicate information, back to a gateway, or they can now use mesh. So that's one of the things that developers really like about Bluetooth is this flexibility. It's not just one way to communicate. I can communicate over a point-to-point connection. I can do it over a broadcast connection. I can do it now over mesh, etc. So it provides a really good, flexible platform for developers to choose what is the right approach for them.
All right. Thank you so much, Ken, for coming on the show this week.
Of course. Thank you for having me.
That's it for this week. Thanks so much for listening. And remember, if you'd like more IoT news, sign up for my newsletter at stacyoniot.com. We'll see you next week.